Hello guys, my name is Melbay and welcome to my programming class. In today's session, we'll be looking at variables. In the previous session, we spoke about statements, how to construct a statement, and how the computer will respond if you pass a statement to it, if you give it a statement. So we describe statement, we practice some of the statement. So I advise you go and watch that video to learn more about statement. In today's session, we'll be talking about variables. So what are variables? Variables are things that do not have fixed values. You get it? So in mathematics, we get questions like find the value of x. I can give you an equation, or an expression like x plus 5 is equal to 10. Find x. So find x. Someone can get x is equal to 10. Someone will get x is equal to 5. People will get different answers. But the thing is, only one will be correct. But people will get different values. Why are they getting different values for x? Because x is a variable. When we say something is a variable, it means the value can be anything. The value can be 10, it can be 5, it can be anything. That's why we say x is a variable. So anything we refer to as a variable do not have a fixed value. It can be anything, and it's at any given point in time. At any given point in time, or how you say it. So in programming, we have the concept of variables in programming, but this time, variable is a term used to represent memory. You get it? When you are programming, you'll be dealing with so much memory. The programmer will be dealing with so much memory. You'll be collecting memory from the computer for different reasons. So you'll be dealing so much with the computer memory. And the memory is called variable. It's mostly termed as variable. Why do we call the memory variable a variable? Because the memory can't contain any value at any given point in time. Today you can store 1 in the memory, and tomorrow you can store 5 in the memory. So the content of the memory varies. You get it? You can't have the memory, whatever you store in the memory can change at any given point in time. You get it? So the memory is called a variable. So the terms can be used interchangeably. So you can either say memory or you can say variable. But in programming field, in the concept of programming, memory, variable is another term for memory. You get it? Because of the nature of memory, anything can be inside at any given point in time. You can't be sure of what is inside the memory. You can initially put 0 inside the memory, and alongside the program, as you are programming, you can change the value, or a user can enter a value into the memory. Then later, as the software is still running, the user will enter a different value into that same memory. You get it? So the content of the memory always varies. That's why we call the memory variable. So it's the same as mathematics. In mathematics, when you say find the value of x, you can get 5, you can get 10. You get it. And one thing I used to say is when we say find the value of x and you get 5 and someone gets 10, it's not a big deal. But when you're writing exams after examination and you people ask, so what did you get for x? And someone says 5 and someone says 10, then that one is a big deal because someone is wrong. One of you is wrong, or both of you are wrong, because x can be anything. You get it? So what you have to pick from here is when we say variables in programming, we are referring to memory, the computer memory. We call it a variable because the content varies. Anything can be in the memory at any time. That's why we use the term variables. And mostly it is even being used more like how it is being used in mathematics, because I can say if my memory name is called A, I can say A is equal to 5 in a program. So we have a statement like this. So in mathematics too, if A is a variable, you can say, okay, so the value of A is 5. In programming too, we can use a term like this, because I told you programming is what text. A program is just text. You get it? So you can see somewhere I want a simple one. I want to say like I is equal to 0. You get it? I is equal to 0. It's like mathematics. I is equal to 0, x is equal to 0. So we use it more like how we use it in mathematics, the concept of variables. You get it? So this is what you have to understand about variables. Variables are other names for memory, the computer memory. So as a programmer, you will be needing the computer memory often to do some processing. And the main reason we need a computer memory is to simplify the program. Maybe we don't want our program to be plenty, so sometimes we'll be using the memory to simplify our program. Or sometimes, anytime we want to take input from a user, we have to use memory. We need to reserve some space in the computer or get a memory from the computer to store that data. We can't tell a user to enter something and we wouldn't have anywhere to store that data inside the computer memory. You get it? It doesn't work that way. So previously, if you follow the previous lesson, we did something like prompt, enter a number, enter a number. So watch. So anything you type here, after you press OK, it vanishes, although it's showing here, but in reality, or when we are writing a real program, you realize that you won't even see this. It vanishes because you can't just take input from a user. You always need to reserve a place in the computer memory to hold that thing so that you can make references to it later, or you can't take user input. In some programming languages, you can't even request for input without even collecting memory from the computer or reserving a space in the computer to store that. It won't work. You get it? So here you realize that inside this guy, the program here, this program here, this statement collect memory from the computer. This is a computer memory. We'll explain it, but this statement tells the computer to, reserve some memory space because we want to store something. And this statement here, this is an instruction that takes input from a user. So this an equivalent of prompts. You see, we have different programming languages. So it's the same thing we want to say, but different ways of saying it. Like English, we say come, and maybe in which language? French, you may say viens if it's correct. But it's the same idea of something should move towards you, but different ways of saying it. So in some languages, we say prompt. In some program languages, we'll use the term prompt. In some program languages, we'll use maybe this one, scanf. You get it, to take input from users. But the most important thing here is you see N. N is the memory we took from the computer, and you can see it here. So before you can take input from a user, you need the memory. You need a memory space to store it. So that's what the programmer did over here. You get it. So ours, we were able to take input without reserving a space in the memory. You get it. We can do that, but after the computer takes the data, it will throw it away. There will be no way to access it again because you never created a memory space to store that data. You get it. So if you study here, my calculator that I built in the previous video, you see this time I'm taking input here, but I'm putting it inside somewhere. You get it? I'm not just doing a prompt. I'm putting it somewhere. Here you can see I'm putting somewhere. This operation is being put somewhere and stuff. You get it? So that's the concept of variables. Variables are memory. And the memory, what do we do with memory? To understand this, variables are memory. It's another term for memory. You get it? So, and as a programmer, you'll be needing the computer memory for so many tasks or operations. So how do we tell, the next thing is, how do we tell the computer to give us memory? Maybe we want our program to take input from a user, or we want a computer memory to do something. How do we tell the computer to give us memory? We do that by using a concept called variable declaration or declaration of variables. Let me type it here. First, let me take these guys down. So variable declaration is a popular term you hear in programming, variable declaration or declaration of variables. This is a term or a concept that means something small. Sometimes it confuses so many people, but the idea is simple. When we say variable declaration, we are just talking about collecting memory from the computer. So if I say to you, declare a variable, all I'm trying to say is collect memory from the computer. So anywhere you hear that declare a variable, all they are trying to say is collect memory from the computer. You get it? Why do we need a memory? Because we want to store user input. A user is going to enter data, so we need somewhere to store it. Or because our program is becoming plain, we need to shorten some, we need to store some of our data inside a memory so that we can ease some of our programming steps. You get it? So the concept variable declaration is a concept that deals with collecting memory from the computer or reserving space in the computer. So, like I said, if you are asked, if we say that declare a variable, all they are trying to say is what? Collect memory from the computer. Collect memory from the computer. That's all it means. Variable declaration is just about collecting memory from the computer. So the second question is, how do we declare a variable? How do we declare a variable? So we know that variable declaration means collecting memory from the computer. So how do we collect memory from the computer? Or how do we declare a variable? You need to write a statement because everything is instruction. I've told you that a statement is an instruction. You get it? So to collect memory from the computer, you need to instruct the computer to give you a memory. You get it? So for me to take memory from the computer, I need to instruct it. Come. Yeah, I'm sorry. I'm sorry. So variable declaration is just a concept that deals with memory. The part of program that deals with memory collection. You get it? So I said when we say declare a variable, it means collect memory from the computer. And we were at how do we collect memory from the computer? How do we declare a variable? So, and I was like, the answer is you need to write an instruction to the computer, you need to write a statement. So to collect memory from the computer, you need to instruct the computer to give you that memory, or you need to write an instruction, or you have to write a statement. So the statement, I'm going to write a statement. Why this. So here, this is an instruction, this is a statement. How did we know it's a statement? We saw that it's ended with a semicolon, and it's a single line of instruction that can tell the computer to do something. It's full, it's meaningful. It's a meaningful instruction that can tell the computer to do something. And it also ends with a semicolon. That's how we know it's a statement. If you want to know more about statements, you need to watch the previous video. So this is a statement, and this statement instructs the computer to give us memory. You get it? When we pass, it looks like just text. I just typed it. But if I give it to the computer, it will reserve a space in this computer I'm using, to reserve a space in the memory. You get it? So if I pass this to the computer, this instruction to the computer, a memory space will be reserved in this computer, the computer I'm using. A memory space will be reserved there. So that's powerful. That's powerful. So I mean, programming, you realize that you are writing text, but once it's being given to the computer, things happen. Yeah, bigger things happen. So to collect memory from the computer or to declare a variable, you need to write a statement or an instruction. That instruction is made up of two parts. The instruction is made up of two parts. One part, mostly, you can see here. Let's go to this guy. It explains it well, this guy. So there is variable declaration. There is a command that tells a computer to give you a memory space. So the programmer is telling the computer to give him a memory space or a computer memory by writing this. So this is statement. And I said the statement that instructs a computer to give you memory is made up of two main parts. One part tells the computer the type of data you will be storing. You get it? You will be storing in the memory. And the second part, and here, tells the computer the name you want to give to that memory. You get it? So one part, there's an int, tell the computer the type of data you will be storing in the memory. And N will tell the computer the name you want to give to the memory. So when we run this command or we pass it to the computer, a memory space will be given to us, and it will be taken from the integer section. So listen, we assume that the computer memory is made up of different sections. We have a section for storing integer numbers. We have a section for storing text. We have a section for storing decimal numbers. So to tell the computer to give you memory, you have to let the computer know where it should pick the memory from, because the computer will be confused that should I pick the memory from the decimal section or from the integer section or from the text section. So we specify it here as part of the statement. So here we've written int. Int is the short form for integer. So this one will tell the computer that, oh, take the memory from the integer section. And the N here tells the computer the name we want to give to the memory. The reason why we name our memories is you can take lots of memory from the computer. I can take like 5 memory from the computer. So how would I be able to identify each of them and know the one I'm interacting with at the moment? It's through the name of the memory. So anytime we are collecting memory from the computer, we need to give the memory a name. So we specify 2 things: where the computer should take the memory from and the name we want to give to that memory. You get it? So that's what we call variable declaration, collecting memory from the computer. In this case here, you saw the other one, we had something like int A. Here, int A2. And this statement takes memory from the computer. But over here, we are writing something like var A. What's the difference between this guy and this guy? The difference is they all do the same thing. There's a command that tells a computer to give you memory. There's a command that tells a computer to give you memory. But this one is a different way of writing it. You know, this one belongs to a different programming language, and this one too belongs to a different programming language. You get it? So this is a C language style of taking memory from the computer, and this is a JavaScript way of taking memory from the computer. So we will be using the JavaScript way because it's simple. When you use the C style of taking memory from the computer, like int A, this part will tell the computer where it should take the memory from. So int means integer, so it will take the memory from integer section. And the A is the name you want to give to the memory, so that at any point in our program, we can refer to that memory with A. So look here, you can see here, we declare the variable N. To declare a variable means to collect memory from the computer. So if I say declare a variable, it means collect memory from the computer. To collect memory from the computer, you need to write a statement or an instruction. The statement or instruction is made up of 2 parts. One part tells the computer the type of data you will be taking or storing, and one part tells the computer the name you want to give to that memory. So you write this statement and the computer will give you memory. So in cases in programming languages that uses these guys, the int A and stuff, you notice that here we've specified that we'll be storing integer numbers in the memory. So we can't later go and store maybe decimal numbers or text inside that memory, because we told the computer to give us memory from the integer section. So we can only store integer values inside. We can't store text. If we try to store text or decimal numbers inside that memory, our software will crash or the program will crash, because we don't store text or decimals in the memory that the computer offered to you by writing this instruction. You get it? So if you want to store decimal numbers, you need to write this. You have to change this type here. You have to, this part of the statement, to double. So this command, this statement will tell the computer that, oh, give me a memory. I want to store decimal numbers. If I make it this way, string A, I'm telling the computer that give me a memory. I want to store text inside. You get it? Meaning I can only store text. You get it? If I make it double like that, it means I can only store decimals. If I try storing text inside this memory called A, it will cause a problem. But in JavaScript, There's this good thing about variable declaration. You can just say var, var, and just bring the name of the memory. So you can just specify that it's a variable. Yeah, you are trying to declare a variable by just writing the var and just bringing the memory name. Get it? So this statement will take a memory from the computer and it will name that memory E. But this time, we don't know the type of data that will be stored inside. And it's a good thing because in this one, if you look at this guy here, look at this guy, we've written int. So we know that the memory will accept only integer values. But here we've written var, meaning we don't even know what values will be storing here. The reason why we do this in JavaScript is it's cool. It's a very nice feature. It's because when you do this, when you write var and a memory name, what the computer does is it doesn't go and take memory from the integer section or the decimal section or the text section. It will wait for the user. It will give you memory. You get it? But it will, okay, let's say it this way. The computer will wait for you to try and put something in the memory. So based on what you want to put inside the memory, then the computer will know that, okay, you want memory. It has to take memory from the integer section. So let's see something. If I say maybe A is equal to 5, if I write a statement like this means that I'm trying to put 5 inside the memory that I collected from the computer. The memory I collected from the computer is called A. I'm trying to put 5 in. So it's through this number, what I'm trying to put inside this memory, that the computer will be able to determine where it should pick the memory from. So here, the computer will know that, oh, okay, now I have to pick the memory from the integer section. So this is a great feature. With this one is, this one is very rigid. When you say int n, this one, the computer takes the memory from integer direct. So you can't put text and anything inside. But if you use this language, JavaScript language, you can just say var A, and the computer will determine where to take the memory from depending on the value you try to put inside the memory. You get it? So that's the good thing about variables here. So one thing you have to pick here is all you have to know here is just know how to collect memory from a computer. How do you collect memory from the computer? In this situation, we just say var to tell the computer that it's a variable we are dealing with variables, so we are trying to collect memory. Then we bring the memory name A. Then we bring the semicolon because the whole of this is a statement. So anytime you see something like this, it means we have collected memory from the computer. We've declared a variable. So if I say something like declare variable A, this is how we do it. If I say declare variable B, VARB, declare variable C, VARC. What does declare variable means? When I say declare a variable, I'm trying to say that collect memory from the computer. So when I say declare variable A, I'm saying that collect memory from the computer and name that memory A. And there is the statement that does that. If I say declare a variable B, I'm saying that collect memory from the computer and name that memory B. So when I'm going to say that collect memory from a computer and name that memory D. Okay, so var D, this is how we take memory from the computer. This instruction that tells the computer to give us a memory. And the D here is the name we've assigned to the memory. You get it? So variable declaration is same everywhere, just that they've introduced ways to take the memory. There are times that you have to tell the computer the type of data you'll be storing there. And there are times that you just have to tell the computer that you need memory. And you let the computer decide where it should pick the memory from, whether it should pick it from integer section or decimal. The computer will decide. You get it? So we have two ways. We have the dynamic way. You say dynamic type or something. You don't have to get technical. So let's clear the screen. The statement for clearing the screen is clear. So now we've learned how to declare variables. Now we've learned how to collect memory from a computer. So how do we collect memory from the computer? We can just say var and give the memory, bring the memory name. So var is a short form for variable. It's just variable we are trying to say. You get it? So variable. Then we bring the memory name. So X. Then we bring a semicolon because it's a statement, and statement ends with semicolon. It's an instruction. So this thing you see here, var X, is an instruction. It tells the computer to give us a memory. And the X here will tell the computer that the name of the memory should be X. You get it? So I'm working on a program. Let's say I'm working on a program and I need 3 memory spaces to store 3 things. I can declare 3 variables, or I can collect 3 memory. So I start with, okay, var A, bring my semicolon to make it a statement, a full instruction, then I'll send it. So now I've collected 1 memory called A. I'm going to collect a second memory called B, var B. I've collected a second memory called B. I want to collect a third memory called C. So just say var C. So this way is simple. You can see that this is simple. Using the var and the memory name is simpler than this guy, than writing the type of data or indicating where you actually want to store it. Because if you use this and you bring your memory name, if you declare a variable this way, it means that you can't put anything else inside. You just have to, you can only put numbers inside. But if you declare a variable this way, you can put anything inside. Today I can put 1 inside, tomorrow I can put a text inside, the next I can put decimal inside. That's the benefit of using this type of variable declaration method. You get it? So what are variables? Variables are just memory in a computer. You get it? And we call the memory, another term for the memory is what we are saying variables. The reason why we call the memory variables is the content of the memory varies. You get it? The content inside the memory can change at any time. Today I can put 2 in the memory, tomorrow I'll put 5 in the memory. That's why we call them memory variables. You get it? And you will need memory to perform certain operations. As a programmer, you'll be needing memory to perform certain operations or processing. You get it? And to do that, you need to collect the memory from the computer by writing a statement or an instruction. And the way we collect memory from the computer is by just, in some situations, we just say var and we bring the name of the memory D. So the var is just a short for variable to tell the computer we want to create a variable, we want to declare a variable, we want to collect memory. Then here, this part will stand for the name we want to give to the memory. So it's simple. Now we can declare variables. Now we know how to declare variables. Now we know how to collect memory from the computer. So one last time, I'm going to say this. We are going to collect a memory from a computer and name that memory A. So how do we do it? var is a command. Now when the computer sees var, it will know that we are trying to take memory. Then the computer will see A. Then the computer will know, okay, so you are trying to take a memory and you've given the memory a name A. You get it? And now this is your semicolon showing that this is a statement or an instruction. So when press enter, it's being sent to the computer and the computer has responded. You get it? We'll talk about that one later. So let's try some. Declare variable B. I'm giving you a task. Declare variable B. Declare a variable B. So how do we do it? var space B. Yeah, done. Declare a variable C. var C. Declare a variable Tim. var Tim. Yeah, sorry, the hash. Declare a variable number. var number. You get it? So what have I done here? Here I've collected the memory from the computer and I've named it A. So this instruction collected memory from the computer and named that memory A. This instruction collected another memory from the computer and named it B. This instruction collected a third memory from the computer and named it C. This instruction was wrong because the hash So it wasn't a correct instruction. So I rewrote it again. So vertim. So we've collected a memory from a computer and we've named that memory Tim. So you can name a memory, you can give memory different names. The name of a memory can be letter or it can be a word. But there are rules. There are rules. You can check it out. You can just type variable declaration rules. Oh no, variable naming rules. Which type of names can you give to your variables or can you give to memory? You get it? So we have some rules. You can't just say maybe one var 1a. Let me press enter and see. It gave me error because we don't declare variable that way. The name of a variable can't start with number. You get it? So there are rules. But so far we won't be crossing them. There are rules, so let's forget about them. So now we know what variables are. Variables are memory, and now we know how to collect memory from the computer, or we know how to declare variable now. The next thing is we know that variable or memory, we know that we need memory from the computer to do certain things. When we take memory from a computer, there are two main things we can do to the memory. So get this right. Anytime we collect memory from the computer, there are two main things we can do with our memory. We can either read or write. So anytime we collect memory from the computer or anytime we declare a variable, there are two main things we can do. We can read. Read means checking whatever is inside the memory. You get it? And write means putting something inside the memory because you took the memory to use it. So when you pick a memory, you need to write something inside. So storing something in the memory is called writing to the memory. You get it? And checking whatever is being stored in the memory at a particular time is called reading. So we are going to declare a variable or we are going to collect a memory and name that memory A. So we do that by writing A-E-R space, then bring A. You can bring as much space you like before you bring the comma. It doesn't matter. That's it. There's the var in the A, vara. It can be vara. There should be space like that. Okay. So now this is a statement. And what does this statement do? It tells the computer to give us a memory and the computer, and this is the name we want to give to the memory A. So this statement tells the computer to give us a memory and name that memory A. So anytime we want to refer to that memory, we'll use the name A. Anytime we want to interact with that memory, use the name A. Anytime we want to read that memory, we use A to reference it. Anytime we want to write something to the memory, we use A. So you can see from here, this guy, the guy that used here, int n. So this is also variable declaration. These instructions tell the computer to give us memory and we'll be storing integer numbers inside. That's why we use int. We didn't use var here. We use int to tell the computer that we will be storing number inside the memory. So give us memory from the integer section and name that memory n. So anywhere we see n in our program, we are actually referring to the memory. So over here, we can see n, meaning we are referring to the memory. Here we can see n. We are referring to that same memory, n. So anywhere we want to use the memory in our program, the particular memory in our program, the memory we've collected, we just use the name that we gave to it here. So you see here, we are interacting with the memory n, name called n. Here we are interacting with the memory called n. And where else? Here too, we are interacting with the memory called n. You get it? So here, so I said you can do two main things when you collect memory from the computer. You can read or write. So now we've collected a memory from the computer by typing this. And you know I told you that anytime you press enter, the instructions will be sent to the computer to respond. So when I press when I press enter, the instruction here was sent to the computer and the computer responded by showing us something called undefined. What does it mean? Anytime we create memory, in this situation, in the language I'm using to do the experiments or the practicals, anytime we declare a variable or we collect memory from the computer puts something called undefined. The computer puts a text called undefined inside. So let's see. Oh, oh no, it doesn't put. It puts now. Oh wait, I think but okay, it doesn't put undefined. It's undefined. Let me see. Is it really working? Oh, I thought it was undefined. All right. In most situations, in different programming languages, when you declare a memory, when you collect memory from the computer puts an initial value inside. Sometimes the computer puts 0 inside. Sometimes the computer puts empty, nothing inside the memory. The memory is empty. And this guy is supposed to put, I don't know, okay, so it puts now rather inside the memory. Let's see. B. Let's see. Okay, so this is what happened. Now let me explain what's happening. So first we told the computer to give us, let's collect memory from the computer. Let's declare variable. So I'm going to say var a. So now we've collected memory from the computer called a. So we are now going to press the enter. When we press the enter, the computer will reserve a memory space for us. Right now we've not collected, we've just typed. So when I press enter, an initial value has been placed inside the memory A because nothing is inside. So let's check what is inside A at the moment. How do we check what is inside the memory called A, the memory that we just collected? We just press A. I still have, oh, sorry. Something was inside the memory already. Something was inside the memory. Let's use a random memory. Let's create something like, okay, let's use var n. I'll explain why we had 5 inside later. So let's say we've declared a variable called n. You get it? We've declared a variable called n. Let me still use a. I want to use a. So let me refresh this page. Why is this thing messing with me? The other time it plays now inside. Now it has plays undefined inside. I don't know why this thing is messing with me. So let me clear it. So this what happened. We declared a variable. How do we declare variable? We declared a variable called a, and we wanted to see what was stored inside the memory at the moment after collecting the memory. So to do that, you just type the memory name by writing maybe a. When you write a, you see this faded text. This is what is inside the memory at the moment, undefined. It was supposed to be undefined, but I don't know why the previous one, it was now. I had now inside. Okay, I think I had used the variable a somewhere up inside. So I think that's why it was acting that way. Okay, let's see. D. Let's create another variable called D. Let's check what is inside D. Okay, I know why it was now, but I don't want to explain it now. So when we create a variable, yeah, in this language programming, in JavaScript programming language, an initial value or text called undefined is placed inside because nothing is inside. That's why they've stored undefined. So you can put things inside the memory later. Now we've collected a memory called D here. So we want to put something inside the memory. How do we put things inside the memory we've collected? We use something called assignment operator. So equal to this symbol equal to is called assignment operator. Assignment operator is used to pass data or write data into a memory or store data into the memory you've collected. You see, so I want to collect memory from the computer, a memory and name it a, var a. I've collected memory from the computer. And initially we have the value undefined inside. How did we know? We can just type a and we see undefined came. So it means the value inside the memory A at the moment is undefined. So now we want to put a value inside the memory called A. How do we do that? We just have to write the name of the memory A, bring the assignment operator Assignment operator is used to write data inside the memory or store data inside the memory you've collected or declared. So yeah, after bringing the equal to, you can put your data, you can write the data. So let's write 5. When I write 5, I bring my semicolon because this is a statement. It's an instruction that can tell the computer to do something. What will this instruction tell the computer? It will tell the computer to store the value 5 inside the memory we've collected, the memory A. See, we collected the memory A here, and we are saying that the computer should put, we are writing an instruction here that the computer should put 5 inside this memory. So when we press enter, it will happen. So now this time, let's see A. You see, before, after declaring the memory, we typed A to see, to read the memory, to see what is inside the memory. We got undefined. So we are going to type A down here to see what is inside the memory now. So what did you see? What can you see here? 5. Now, inside the memory called A, 5 is inside. This time it's not undefined. So anywhere we type A, we'll get 5. Because anywhere we type A, we are referring to the memory that we declared as A. We collected and named A. Anywhere we type A, you see that 5 is inside the memory. So when we type A, we are reading the contents of the memory. I told you reading means checking what is inside the memory, and writing means putting something inside the memory. So over here, this is writing. We wrote 5 into the memory. We put 5 into the memory. And here we are reading. We just write this to see what is inside the memory. So now I want us to put something else inside memory. So A is equal to 10. So I've written another statement. In this statement, I'm putting a different value, 10, inside the memory called A. So I'm done. So now let's check what is inside A. You can see that now it's 10. 10 is inside A. A is no longer what 5. Okay, let's put a different value inside the memory A. So how do we do it? A is equal to 15. Bring the semicolon. Now let's check A. 15. So A is now 15. You get it? So anytime you collect memory from the computer and you put a value inside, if you try putting another value inside, the old value will be erased and the new value will be inside. So here our statement or our instruction to the computer to put 5 in the memory A. When we checked A, it was 5. We checked it again, it was 5. Here we placed 10 inside the memory A. We checked and we checked here. When we checked, it was 10. And now we've placed 15 inside A. Let's check 15 by typing A. And you see, it's 15. It's written 15 here. You get it. So anytime you have memory and you have something inside, you always have to know, you always have to remember the name of your memory, because you can always overwrite it. Overwriting means there's something inside and you've put something inside to erase it. You get it? So we are overwriting it. It's not a good thing. So that's it for memory declaration. I'm not really done, but let's explore a bit more, because I think I didn't really start well, so it was becoming a bit confusing. I'm sorry. So let's collect memory from the computer and name that memory B. How do we do it? V-A-R-E. We bring our semicolon. So now this is a statement. Why is it a statement? It ends with a semicolon, and it's a full instruction that the computer can understand and perform. You get it? Perform the action. So what we've done here, this is statement, and another term that we use to describe this is variable declaration. If we see this, we say that we've declared a variable called B. You get it? So anytime you see something like this, you can just say that we've declared a variable called B. Inside this guy, if you see something like this, you see that we've declared a variable called N. Get it? So here you see we've declared a variable called B. What does declaration of variable means? Declaration of variable means collecting memory from the computer. So here we've declared a variable called B, or we've collected the memory from the computer and we've named that memory B. So when I press enter, we are now going to collect the memory, because I've just typed it. So right now we've not been giving it to the computer to create the memory for us. So when I press enter, now it has been passed to the computer. So the computer has printed undefined here, meaning that it has created this memory for us. It has given us a memory called B. And whatever is inside the memory now is what's undefined. The term, the value undefined has been placed in. How do we know? Let's read B. By just typing B. When we type B, you can see it here. It's faded here. It means undefined is inside. We can put something else inside B. We can put 8 inside B. Let's put the value 8 inside B. How do we put data inside the memory we've collected? You just have to bring the name of the memory you want to put data inside. You just have to specify it here. Then you use the assignment operator, which is used to send data into a memory. Then you put the value you want to put here at this side, at the right side. So the left side contains the memory, the name of the memory you want to put data inside. And the equal to assignment operator tells the computer that we are trying to assign the value at the right side to the value at the left side. You get it? So this, like mathematics, just like we say that B is equal to 8. B is a variable. After solving B, we had B equals 8. You get it? So it's more like that, but it's a bit different. So B is equal to 8. What is happening here is we are putting the value 8 inside the memory called B. And we did that by writing a statement, an instruction. We are not just saying it and it's 8 is going inside B. We wrote a statement and boom. Now 8 has been stored inside B. When we first declared the variable B, when we first collected the memory and named it B, the computer placed the value undefined inside the memory called B. Now we are here and we are changing the contents of B. So before we have undefined inside the memory code B. So here, there's an instruction that tells the computer that put the value 8 inside the memory code B. So this time, if we type B here, we are not going to get undefined. We are going to get the value inside B. So let's type B. Now you see, we saw 8. So 8 is inside the memory code B. So that's how variables work. Variables are just memory, and we use them to store data. You get it? So that we can always remember and we can always refer to it. So we store data for future references. So we use memory a lot. Programmers rely on memory. Get it? So that's it for variables. I don't want to talk much, otherwise this video will be so much. But that's it for variables. So let's practice this. We want to create 3 variables. So let's create 3 variables. Let me clear the screen. So I want to give you this exercise. I want you to create 3 variables, meaning I want you to collect 3 memory from the computer. So collect 3 memory from the computer and name the first memory X, name the second memory Y, and name the third memory Z. How do we go about it? We need to use the command VARX. So this statement will tell the computer that give me a memory and name that memory X. We'll create another variable Y. This one to tell the computer, give me a memory called Y. Give me a memory and name that memory Y. And var. Yeah. So var Z. So give me a memory called Z and name the memory Z. So here, so instead of saying give me a memory code X and name that memory X, you can just say declare variable X. It's the same thing. Declare variable Y, declare variable Z. Collect memory from the computer and name it X. Collect memory from the computer and name it Y. Collect memory from the computer and make it Z. So it's easier saying declare variable X than saying collect memory from the computer and make it. It doesn't really sound, professional. So when you say declare variable X, although behind the scene, we know that we are collecting memory from the computer and we are naming that memory X. You get it? So now we've collected 3 memory from the computer. We have memory X, memory Y, memory Z. Let's check what is inside the memory called X. X, undefined, nothing is inside. The text undefined is inside. Let's check the memory called Y. We have undefined stored inside. Z, undefined. So undefined actually means that nothing is inside. We don't know. It's undefined. We don't know the value that is inside. It's nothing. But it's the text that has been stored inside. At least we know it's a text. So I want you to take memory Y and put the value 6 inside. How do you do it? You just reference the memory. Okay, memory Y, and we use the assignment operator, and we put the value 6, and we bring the semicolon to mean to form the statement. So this is an instruction. When we give it to the computer will put 6 inside the memory called Y. So this time, when we go to Y to see what is inside Y, we won't see undefined. We will see the value 6. Let's see. So let me just do some random something here. Let me just bring X. Let me just bring Z. So you can see here, X is still undefined because nothing has been placed in X. Z is still undefined. Nothing has been placed in Z. Let's see why. Why? Why is giving us what? 6. See, Y is giving us 6. Meaning 6 has been placed in Y. How? Where? Okay, up here we place 6 inside Y. Before, when we checked Y would have given us undefined. Over here, after checking Y, you see, well, after declaring it, we saw that it was undefined. Now we have what? 6 inside the memory Y. So variables are just memory. We use them to store data. So here we learned how to use a variable to store numbers. We can also use it to store decimal numbers. So I already have a variable declared already Y. So you see it's declared already, so the 6 has come. I just cleared the console, but it's still declared in the memory until I close this program or I refresh the page. So if I refresh the page, the memory inside here will go. Let's try it and see. So before we have the memory won't exist again. Let's see why. You see now it's giving me an error. Why is not defined? What is Y? You can't just see Y. What is Y? But if we declare a variable called Y, now let's type Y again. You see now it's making sense. It's not giving us the error that Y is not defined. Because now no, Y has meaning in the computer. So the computer knows that okay, Y is a name of a memory. You get it? So this time we've been putting integer numbers inside the variables. This time we want to put this guy inside. We want to put decimal numbers. So how do we do it? Just say Y is equal to the decimal number 1.5. We bring our semicolon. This is statement. We press enter 1.5. So let's see Y. Let's read the contents of Y by just pressing Y. So you can see down here, Y is 1.5. Let's change the value. Let's put 2.6 inside Y. 2.6. Let's press enter. So now this time Y is not 1.5 again because now we've put the value 2.6 inside the memory called Y. So this time Y is what? 2.6. Y is not 1.5 again, it's now 2.6. So we can also put values such as we can put text inside the memory. Y. So Y is equal to, how do we do that? Y is equal to, you bring it to work with, if you want to work with text in programming, you need to put them in double quotes. You get it? So let's put them in double quotes. So let me put my name, Tim. So this time Y is what? Let's send to the computer and see. So Y is Tim. Let's check. You see, Y is now Tim. Get it? Y is Tim. So the good thing about using this, we have the var and we have the int n. So you now see the difference. When I say var n, this time I cannot put text inside the memory code n. I can put decimal number inside the memory code n. I can put integer inside the memory code n. But if I do this int n, which we do in other programming languages, it means you can only put integer values inside the memory code n. If you attempt putting the word term inside n, your software will crash. Your program will just crash. You get it? It doesn't work like that. So that's the cool thing about using variables, like using var n and those var stuff. You get it? It's cool. It's cool. So I discovered it. I used to do C++. I used to work with these guys. I used to do C too. I used to work where's that guy? I used to work with these guys. I used to do int n. And sometimes you tell the user enter a number and the user will enter text and my program will crash. Until I discovered that, oh, in this language, you can even just say var n and the program, if the user enter a number, user enters text crash. we are still going. The program won't crash. So I'll be able to tell the user, hey, I said enter a number. Is Y a number? Is B a number? You get the vibe. Get the vibe. So that's it for variables. I don't want to go deep here because the video, I think, it has become a bit long. It has become a bit long. So I will end for variables here. And let me say one last thing about variables. Here, let me show you an implementation of the variables where I use the variables. You remember the program I built that solves that subtracts two numbers. Let me go up, 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 up. Hey, remember this guy? This program is let me this guy. Hey, remember this program? It takes two numbers, 4 and maybe 1, and it will subtract them and you get 3. So this is a program. Inside this program, what can you say about this program? Let me clear the screen and make it readable. What can you say about this program? You can see that what we are having variables here, var A. You can see var A. You can see var B. You can see var C. What do you think is happening? We collected memory from the computer. This instruction here collected memory from the computer and named it A. This instruction collected another memory from the computer and named it B. And this instruction collected another memory from the computer and named it C. So here we've collected 3 memory from the computer. One is named A, one is named B, one is named C. So now we know how variables work. So in the next session, which is session 3, we are going to learn how to, use the variables. Now we've learned the ideas of variables. This session was to teach you the idea of variables. So the idea of variable is that variables are just memory. You get it? Variable is a name for memory. It's another term for memory. You get it? So variable is used for storing data that we will be taking from the user or we will be using to simplify our programming. You get it? We'll be using to store some data for future references as we program. So that's what variables are. In the next session, we are going to learn how to use the variables. You get it? So here you can see I'm using the variable here to do some things. In the next session, that's what we'll talk about. But in this session, you're just supposed to know about what variables are. The variables are memory. We need a computer memory to store certain things for future reference as we program, or we need a computer memory to take input from users. That's what you just have to pick from this session. All right, so see you in the other session. I don't know, this session I wasn't feeling myself, so some of the concept may be a bit confusing, but still follow along, you get it. Let's go session 3 of week 2, and you are gonna get it. Okay, bye.